Today, I will present our poster titled Quantum Dots from Algae, Preparation and Characterization. The authors of this research are Nelson, Juan Carlos, Samuel, Oscar, Jorge, Hamilton, Carlos, and myself, Alejandro, from Universidad del Salvador. In recent years, algal overgrowth has become a major environmental issue along the Caribbean coasts. A possible strategy to address this problem is the synthesis of algae-based carbon quantum dots. The low toxicity and exceptional optical and structural properties of CQDs make them suitable for diverse optoelectronic applications. In this work, we performed a straightforward and cost-effective approach to synthesize CQDs from green, brown, and red algae samples taken from Misata Beach in El Salvador and Sargassum taken from Hopkins Beach in Belize. The synthesis process involves a single-step thermal treatment of the extracted pigments at 200 Celsius, allowing carbonization and reorganization into nanostructures. The resulting CQDs were optically and structurally characterized using absorption, photoluminescence spectroscopy, and SEM. The synthesis of pigment functionalized CQDs was prepared following a similar procedure reported in our previous works. For results, we have that the characteristic absorption bands of mid-corporin-like amino acids, chlorophyll A and chlorophyll B, are observed from 250 nanometers to about 500 nanometers. The PL spectra also shows banded around 660 nanometers for the three extracted pigments. Now, absorption spectra of the obtained CQD show three characteristic bands corresponding to CC bonds, CO bonds, and CN bonds, respectively. However, we observe a band around 280 nanometers that is not well understood. For the CQDs, the photoluminescence spectra show a cold wall-like emission centered around 500 nanometers. We also attempted to functionalize GQDs using algae-extracted pigments. The yellow PL spectra show a broad emission band centered around 500 nanometers and a narrower band around 660 nanometers. This fact is likely a consequence of the functionalization of the GQDs. In summary, the pigment was successfully extracted from the collected red, brown, and green algae. This pigment contained MMAs and a chlorophyll A and chlorophyll B. CQDs were successfully synthesized using pigment extracted from algae. PL spectra suggests that the high-intensity warm light emission could be due to pigment functionalized GQDs. The origin of the 280 nanometer absorption band in the CQDs and PL bands of pigment functionalized GQDs is not well understood, and further investigation is needed. Finally, we would like to thank all the entities shown in this poster for their support in this project.